Okay, we are live. Welcome everyone to ACDE 162. Um, okay, so today, I guess to start, we've commissioned an impact analysis by DDoB around self-destruct removal. So they'll be here to give us an overview of the analysis. And there's already been some conversations in the last day or so about it, and some, potential issues with the proposal of EIP 6780, and then some counterpoints to those issues. So we can have all of that conversation. And then there's a bunch of stuff around EIP 4844 that's in the works, so it makes sense to cover all of those. And after that, I think thinking about like how Cancun shapes up to be. So whether there are some things we want to add or remove from CFI, there's already some comments about that in the chat. And then Dano has put together a proposal to just align the opcodes that are used across all of the proposed EIPs for both Cancun and the next forks, and then a couple more updates on some other EIPs. So hopefully we get through all of this in 90 minutes. But yeah, to kick us off, Neville, do you want to give us a rundown of your impact analysis of self-destruct removal? And I'll post the link in the chat.
Sure, yeah. Can I share my screen as well?
Yes, please.
Okay. Cool. Yeah, so thanks for hosting. I'm Neville Gregg from DDoB. We were commissioned to do a study for the Ethereum Foundation regarding the removal of the self-destruct opcode, or the change in semantics of that opcode. And the team was basically me, Elias Tsatiris, Civis Lagovardos. All three of us are on the call, so feel free to ask us questions. All right, so the scope of the study was basically to determine the impact of changing the semantics of self-destruct. Self-destruct has recently been used, or throughout its lifetime, to either safely transfer ETH or to perform upgrades ever since Create 2 came about. But there are also some question marks, things like, is it actually being used to burn ERC20 tokens? Things like that. So we wanted to find the affected projects, we wanted to find the impact, and all of these things are colored by the fact that some projects have not been recently used, or they don't have a high balance, they're not part of a known contract. So the impact has to be considered against all of these factors. And the other thing is that we have two different proposals, and we want to see which one, or help determine which one to select, if any at all, right, out of these two. So just to give a little bit of an overview of how self-destruct currently works for those who are external. There's a bit of nuances here, because self-destruct, pops one element from the stack, that's an address, and what it does is it sends all the ETH in the current contract to the beneficiary address. But unlike call, it does not actually create a call frame to execute the beneficiary's code. So it can be used in a way that even for smart contracts that block, the receive function, that block the receive function, then self-destruct is still going to work. It also clears the runtime bytecode of the current address, resets the nonce to 0, and resets all the storage vars to 0. Okay. It does not issue a gas refund, so that's changed, I think 1.5 or a couple of years ago. So how is this going to change in EIP 4758? So very simply, right? It's going to be renamed send-all. It's only going to send the ETH to the beneficiary address, but it's not going to clear the runtime bytecode. It's not going to reset the nonce, and it's not going to reset the storage vars. So that's a simple proposal there. And the way I remember which one is simple which one is more complicated is by the first number. So the simple one starts with a 4, the more complicated one starts with a 6. So in EIP 6780, the semantics of self-destruct are essentially the same as they are now, except that there's a condition that if the address, and by address I mean specifically the opcode address, right, is created in the same transaction, then you do the same thing as in self-destruct. You clear the runtime bytecode, reset the nonce, reset all stored vars. Otherwise, these things will not work. They will not happen, right? Okay, so now that we know which each one of these proposals, what each one of these does, here's a little bit of a summary of what we found in the study. So, so first of all, some of these things are subjective. So these are protocols which we think are affected. Some of them are, we estimated the impact too low because they're more likely to be a false positive. So we have to clarify, for instance, in the case of seller over here, because we've seen some, weird behavior if, the self-destruct instruction is going to change. But essentially, the impact is, quite minimal, especially in one of the in the more complicated proposal, right? So 6780. So yeah, I'll go through these one by one, just give a little bit of a summary of what we saw there. So in the case of Axelar network, Axelar creates contracts and then it destroys the contracts in order to do some safe ETH transfers. Now, we think that it is upgradable, so impact is high, but it is upgradable, so that can be fixed. There is no impact in the case of the Axelar network if the second EIP is chosen, that's 6780. So it can remain operational without any upgrades with the second EIP. In the case of Sorbet, it's similar to Gelato. It's not upgradable, but I mean that's part of the smart contract that uses self-destruct, but it really isn't used much, right? In the case of Gelato, it's used in conjunction with Pine Finance. Again, so Pine Finance, we think it's affected as well. Now, I've skipped Seller. In the case of Seller, that one's interesting because it seems to replay messages from another chain, but the messages ought to be unique. And the uniqueness of this message is used as part of the salt when creating a smart contract using Create2. And then those smart contracts are subsequently destroyed. So we think that in this case, if the messages are indeed unique, then that's not going to be affected. But it's going to take a while, obviously, to go through the entire Seller protocol. It's very complicated. We'd have to look at the way it interfaces with other chains as well. But that's what we think at this point. We'll try to confirm with the developers. Chain hop actually works in a very similar way to Seller. The part that has this issue, JPEG-D is affected, and then 1000 Ether homepage is also affected as well. In theory, but we haven't seen an instance in the past where, like, if we had to replay these sequences of transactions, we would find the same effect. But it is, impacted by this. Okay, so note that all of these things are subjective in the case of estimated impact, but from the point of view of like finding potential protocols that are affected, that is not subjective. We conducted this by looking at past Ethereum transactions, by doing in some cases static analysis of the contract's bytecode as well. So we did cover a little bit MEV bots as well, even though there weren't sources available. Now, if we look at this from a quantitative point of view, right? So the usage patterns. So we looked at blocks between block 15 million and 17.23 million. We measured the number of times, for instance, that create or create2 is used. Quite a few times, as you can see over here, much dominates. There's an order of magnitude fewer self-destructs, but interestingly, most of these self-destructs are used in conjunction with short-lived smart contract creations, as you can see. Now, potentially, this can be impacted by EAP 4758 because there's a short-lived smart contract. It's not going to be removed at the end of the transaction, and so someone else can interact with it. But then this is even more worrying. So metamorphic patterns where a contract is created at an address and then is destroyed in the same transaction. And then in another transaction, it could be like, weeks or months after that, the same smart contract is recreated, and then this one is destroyed. Now, there's been 22,000 instances of this. Now, this pattern will not be impacted by EAP 6780, but it will be like outlawed by this other proposal. And actually, XLR network, this is it's responsible for a few of these. Yeah, and then finally, this is what we were kind of like mostly worried about. So long-lived metamorphic patterns, where long-lived refer to the fact that a contract is destroyed in one transaction and then recreated at another transaction. When I say short-lived, it means that a contract is created and destroyed within the same transaction. Now, in this case, as you can see, it's like 2 orders of magnitude, almost 2 orders of magnitude less than in the previous case, like the number of times that this has happened. So, yeah, I mean, just looking at this quantitatively, it seems like, especially if EIP 6780 is selected, most of these usage patterns will be valid, and this will not be. But then we'll see kind of like most of these 735 upgrades are not actually done in mainstream protocols. They are done in unknown or MEV bots or things like that. So okay, so let me give you an example here of a short-lived metamorphic contract. So a contract which is created and destroyed at an address, and then created and destroyed at another one. I'll share these slides with you guys so you can see, but basically these slides are just they're just a summary of the full document. So as you can see here, destruct here. So this contract is created and destroyed. And in the next transaction, same contract is created and destroyed. So these two are separate transactions, but as you can see, like the same smart contract is created and destroyed. So this is just an example in XLR network. Yeah, we've also looked at some protocols where this thing is done or could potentially be done according to how the smart contract code operates. But for instance, in this case, this is a protocol called Revest. We can look at sample transaction, but there's no need. But basically, what happens is that Revest creates a smart contract, and then I think it transfers an NFT to that when you withdraw. And it uses actually within the create2 salt the NFT ID. So again, this is just an example. If you want to see More of these examples. Look at the full report. Let's wait until this loads up. But essentially what we think is, because of this, so over here, this clone deterministic call over here is going to pass the NFT ID, some entropy from the NFT ID, and then that clone deterministic down the line, it creates a new smart contract and is going to use the NFT ID as part of the salt. And we think that since the NFT ID is monotonically increasing, there's not going to be clashes in the smart contracts that are created. So even though the smart contract cannot be destroyed if the proposal goes through, there are always going to be new smart contracts that are created because of that. So it takes quite a while. I mean, this study was conducted over 2 weeks. It takes quite a while to go through all of these protocols and verify. But all we need to do, essentially now that we have this discussion going on, is just confirm that the ones that we thought were false positive are indeed false positive. Okay, so so one of the other things that we tried to do is to use static program analysis to find possible behaviors that we haven't seen on the blockchain so far, but they may potentially happen. For instance, someone deposits tokens to a smart contract or to some address, and for some reason with the proposal, they cannot be retrieved, right? These tokens. So someone asked a question on one of the forums that is used to discuss these proposals. So what we did for this is first of all, we found all contract factories. So for this thing, we actually performed static analysis to find contract factories, because what contract factories do is that they create a smart contract. So they use something like create2, but they actually within the init code, they would have certain patterns there. Okay. Then out of these, so we find the ones that do create2, and then we applied static analysis. And static analysis, in a nutshell, I mean, this is not the real code, this is a pseudocode, but in a nutshell, what it did is, if it finds a self-destruct in a contract that was created by these factories, and it doesn't have, for instance, an ERC transfer, an arbitrary call like contracts.call and allows you to pass in any data, or there's no delegate call, then potentially you can have funds stuck in this smart contract after the EIP goes through. So we looked at many of these examples. I mean, many of these were MEV bots. Of course, MEV bots don't have verified smart contracts, verified sources. So I had to use our decompiler. It takes a while to go through these implementations, and there's trial and error here. So it's not going to be an exact science, but we thought that all of them were false positives for this particular pattern. So we haven't found any examples of this. Okay, so what was surprising is that there's been a lot of discussion about create2 and self-destruct being used to perform upgrades, but in mainstream protocols we haven't actually found this anywhere. But if you look at the fine print in some of the libraries that are used to do these metamorphic contract upgrades, the UX is a problem when you do metamorphic contract upgrades using self-destruct and create2, because you cannot do this atomically. So you have to do this in 2 separate transactions. Now imagine doing a governance proposal where you propose, in one transaction you do something, and then in the second one you have to recreate the smart contract. And then in the meantime, people might go in and use the protocol with the smart contract not recreated. So that can cause all sorts of issues. And then the other thing is that the state setup. A mainstream protocol would have, quite a bit of state that needs to be recreated when you do a self-destruct and create two. So that's not used much. It's mainly used in MEV bots. And there's arguments to be made as to why, for instance, MEV bots would use that, because it's like more efficient to do it that way. You don't have proxies. But maybe we'll hear about this in the rest of the meeting. So, in summary, we think the impact is moderate. It's like, and especially so with EIP 6780. Like EIP 6780 is not going to affect mainstream protocols. Metamorphic contract upgrades are low. One thing that we found is that even though there's a lot of discussion about self-destruct being deprecated, people are still using it, equally so, irrespective of the usage of the Ethereum blockchain. Again, but very rarely, right? And also throughout the study, there was a coincidence that there was some evidence of self-destruct being harmful as well. So yeah, that concludes my, just the summary here, and I think we'll be discussing a few things throughout the call. And if you have any questions, just ask me or my colleagues on the call. Thank you.
Thanks a lot for the presentation. That was very good. I guess
Thanks.
before William.
Share this here.
Oh, thanks. William, I see you have your hand up. Before we go into the set code stuff, I just want to ask, does anyone, I guess, on the client teams or others have questions about the presentation or the report in general? And then, yeah, after that, we can go about, next steps for the specific proposals. But just, yeah, any questions, thoughts, comments on the report or presentation? Okay, and then if not, I guess, where we were at prior to this report was that we included 6780, which is basically the second proposal mentioned in the presentation, and allows self-destruct if it's within the same transaction as create call. And so, William, you raised a couple cases where this could break things. Do you want to take a minute to walk through those? And yeah, we can take it from there.
So I'm a user of the create to upgrade pattern. I have a prepared statement. So the report skims over MEV, but doesn't speculate why this upgrade pattern is common among MEV bots who wrote their contracts in assembly. The reason is broader than MEV and applies to normal DEX trading. Indeed, any actor trying to get competitive transactions included with any urgency must participate in priority gas auctions. Off-chain systems are being built to allow anyone to participate in these auctions. Such auctions are denominated in gas used, so any upgrade mechanism with any gas overhead whatsoever cannot be used competitively. That leaves code replacement as the only viable mechanism for traders. Suppose I want to be able to upgrade my code in order to trade on the newest protocol. It is much simpler now when I'm able to replace the code. Without this ability, I would need to redeploy to a new account instead. Every NFT, every token balance, every token protocol approval, every staking deposit, every registration, indeed, my entire presence on the chain has to move over to this new account. Accounts are identities, and moving all your possessions to another account is painfully expensive. If your account is a smart contract, having a secure way to upgrade it can avoid such a migration. Indeed, this is the purpose of several of the mechanisms identified in the report. Such systems are inventing ways to secure the upgrade process for the masses. Self-destruct removal destroys their work. Set code inclusion renews it. We can preserve the ability of accounts to change their code by including set code in the same fork. Systems anticipating the fork can prepare by including set code. If set code is not included in the same fork, we cannot securely anticipate what the semantics will be. It is critical for adoption of smart contract wallets that we preserve code mutability. Aside, I've had some discussion in the topic channel on Discord, and it seems that it would be a significant improvement for static analysis if we also disabled set code during delegate call. And this would indeed limit the scope and risk and make it much easier to identify potentially mutable contracts, because you would just be looking for the opcode. Another note is that there's, I forgot that. Anyway, I'm going to read your responses now.
Thanks. And then, okay, we had a lot happen in the past day. Yoav put like a set of security concerns he had about set code in the Discord. I just shared him here. He unfortunately couldn't make the call. And then I think what it boiled down to in the Discord right before I hopped on this call was that basically, if we want to introduce set code as a mitigation for some issues caused by 6780, there are some security concerns with that. The worst of them have to do with using set code within a delegate call, and maybe we could enable set code without enabling it in delegate call, and that would resolve some of the issues. And I guess oh yeah, Maris, go ahead.
Yeah, I have a quick question. Can we add set code later on? Is it possible to add this opcode later on?
If we,
or is it
assuming we do remove self-destruct, right? That's what you're asking.
Yes.
So in order to allow contracts that are currently upgrading with self-destruct to remain upgradable through the upgrade, it would be better that we don't have downtime in which code mutability is not possible. And also it's important to solidify that opcode so that at the time of the upgrade, the contracts that are frozen are able to be prepared for the set code upgrade. So it's better that they happen in the same hard fork.
Is it technically impossible for them to be separated out?
What do you mean by separated out?
Is it possible for them to be in separate hard forks?
Well, I guess if I understood correctly, this means yes, but the contracts that are affected are basically bricked between those hard forks, right?
Of it, and I don't really think we should include this opcode now, and I also don't really think we should include this opcode in the future, but we can have a debate about that in order to unstuck or like make it cheaper for MEV bots to extract MEV. I don't think. I think this opcode has a huge amount of security implications, and we shouldn't YOLO it.
Thanks, Guillaume.
Yep. I mean, basically, a lot of it, Marius already said. Yes, it's. I think it's a huge security issue, but the biggest problem, my question still would be, if any of the arguments that were just given in the statement were true, or at least were significant enough to make us consider including set code, would that not be like would not simply not removing self-destruct be the superior solution? Like, does set code offers something that not removing self-destruct would not solve in a better way?
Yes. So the weakness of the self-destruct upgrade pattern is that there's a downtime in the upgrade itself, because the self-destruct takes place at the end of the transaction rather than during it. So you must self-destruct in one transaction and then in another transaction recreate the contract. Set code would allow us to upgrade safely and securely in place. If you all want more time to analyze set code, please just postpone self-destruct. Thank you.
Thanks. Ben?
If set code and a self-destruct depreciation happened, wouldn't set code need to be in a fork before self-destruct? Because otherwise you couldn't upgrade the contracts to use set code without putting invalid opcodes in. Because if self-destruct happened first, then you can no longer upgrade the contracts. And if it set code didn't exist beforehand, so you can't upgrade it to use set code.
Yes, so I think it can be in the same hard fork because contracts can contain invalid opcodes.
Okay, so people would basically deploy the contract with an invalid opcode prior to the fork, and then the opcode would become valid after the fork. Is that right?
Yeah, but they would be dead contracts during that time.
Yes. Yeah, I guess I'd be curious to hear generally from, client teams, given all of this, how do people feel about 6780 set code? Like, do we want to basically, I think that, the first question is we agreed to like have 6780 in pending the results of like the impact analysis and making sure that like not too many things would break. Are teams comfortable leaving it in regardless of what we do with set code and analyzing that separately, or do we feel like the remaining inclusion of 6780 should be dependent on set code?
I think we should leave 6780 in Cancun and analyze set code separately.
Okay.
I feel the same way. We should have 6780 as soon as possible and think about set code more thoroughly.
Could we perhaps finalize the opcode reserved for set code such that bricked smart contracts might eventually be unbricked in a future upgrade?
Yeah, we have a whole section about opcodes later on. Dano's put a full list, so I assume we can at least, quote unquote, reserve one for set code. Yeah, and we can discuss that as part of that. I guess, yeah, okay, so Aragon, Geth on board with leaving self-destruct as is. Anyone else? I guess, does anyone disagree with that? Does anyone disagree that we leave it, we leave the EIP 6780 in, we keep discussing set code, it may or may not be included in this upgrade. And clearly, just in the last 12 hours, there was a ton of discussion, so there's still a lot of back and forth, but does that make sense to people? Okay. Okay, so let's do that. Yeah, so no actual changes to the fork inclusion list. And yeah, I'll make sure to share. Well, I guess if anyone wants to read the full impact analysis for self-destruct, it's linked in the agenda, and so people can see it from there. Okay. Next up, EIP 4844. There's a ton of PRs, some DevNet updates, some potential changes for the next DevNet, and then some RLP and SSD changes that might affect our currently CFI EIPs. So I guess to start off, like client, you had PR 7062 that adds data gas use to the block header. Do you want to briefly discuss this?
Yeah, I just wanted to see if there was any interest from other EL devs. I'm not sure if Peter is on the call, but while he was implementing some things related to sync, he just kind of noticed that there were some, it was a little bit different interaction with the sync code than he was expecting. And after digging into it, we kind of realized that the excess data gas and the base fee are not as similar as we initially would have anticipated them to be. So ultimately the issue is that for excess data gas, it's kind of, that number is going to be used in the block, the descendant block. And so the value that you need to compute the cost of the data transactions is actually the excess data gas from the parent header. And for base fee, it's slightly different. The base fee in the header is actually the base fee that's used during the execution of transactions. And so whenever you do your header validation, that's when you are checking that the base fee is computed correctly from the header. This is kind of just a proposal. I was sort of sketching out what it would look like to bring those two things in line so that they both are representing the value for the currently executing block. And so that's kind of what that PR is. They both do essentially the same thing. I think ultimately the question is just, do we care enough about having these similarities to try and make this sort of minor change, or are we okay with the status quo? Personally, it's just like one of these things. It's another one of these things where if we have the formatting slightly different, it increases the overall code complexity of clients, like we saw as Peter was implementing the syncing code. Whereas if if we had a similar mechanism already and we just reused that mechanism in mostly the same way, it would have kept things a bit simpler. So that's my thoughts. Probably slightly favor the data gas used approach in the PR, but I'm curious what other people think about it. Oh, Peter's here too.
Yeah. So perhaps just a slight thing, I maybe just an expansion to what Matt said, that I think the complexity comes from the fact that previously we had the fee is defined by the base fee. And so essentially we have two header fields. One of them tell us how much gas we consumed, and based on that we can validate the base fees from header to header. And the base fee itself, if I want to run the transaction, I only need to look at the current block's base fee. And with the block transactions, we kind of merged these, how much we use and how much does the next one cost, into a single field. And because it is a single field, it makes basically everywhere where previously when we validated the header chain, we just looked at the header fields. We didn't care about the block content at all. And then when we ran the block content, then we just needed to look at the current header. And since this field somewhat got convoluted, it somehow means that I need to be able to both look at, so when I'm running the blocks, I somehow need to both look at the current header and the parent header. Similarly, when downloading via SnapSync, because there even if I'm not running the block or executing block, I still want to verify the block body. And the thing is that it doesn't really matter how we interpret excess data gas, whether it's for pre-execution or post-execution. The thing is that if I convolute these two fields together, I will have this extra complexity that all validation code will all of a sudden need both the parent header and the current header. Yeah, whether this is something worth, I mean, one solution is to go with the current status quo and make the code around this structure a bit more complicated. The other solution is to split out the two fields so that it follows a similar pattern to base fee and gas used. And if you have the two fields and the code around it become a bit simpler. Yeah, it's not that complicated. It was just something that was surprising to me, that it's a new mechanism, something that was kind of unexpected.
Thanks. Andrew?
Yeah, I think in Aragon we have separate stages for headers and bodies. So I would be very much in favor of making the change so that we don't need a parent's body to verify a block. So yeah, I'm totally in favor. Because just to double check. So with this change, we only need parent's header, not parent's body, correct?
No, actually, so what the current thing requires, if you want to verify the current block's body, you need the parent header. So that's the weird thing, that the current transactions require the parent's header.
Mm-hmm.
That's what the weirdness is. With the proposed change, you could verify the headers completely separately. And then when you want to run or execute a block, you only need to look at the current header. You don't need to look at the parent header at all. So that's how currently everything else works. But it requires this field being split out. So that's the cost.
I see.
So for example, for us, the complexity was that when we are snap syncing, we essentially also have this two-phased thing where we download the header separately, and then for every header, if the transaction hash is not empty, meaning that there are transactions, then we download the block body, and just fill the header. And up until now, we just said that, okay, I want to fill this header. I downloaded the body contents, and then I just match it. Does this transaction list match what the header wants? And if yes, great. And now with the block transactions, what I need to do is that after I'm downloading the list of transactions, what I need to do is that, okay, but now does the excess data gas also get computed correctly, for which I think I need the parent's excess data gas. It gets a bit funky. It's doable. So the way we did it is that from now on, our downloader, instead of a download task is a single header, it's actually a header and its parent. So I mean, it's not specifically complex, but for example, it makes, if you interrupt synchronization and resume it, then you all of a sudden need to dig up the parent of the first header. And yeah, just these little tiny weirdnesses all over the place where up until now, you just had a single header and now you just need two. And it makes things wonky. But again, the question is it worth it to add an extra integer to the header field, or is it too much? And I don't want to make this decision really, because the current design isn't that painful. So if people say that it's not really worth it to stir up the wasp nest for it, then I can live with the current whatever design is.
Yeah, I mean, I think like this one simple thing is really not that big a deal, but it's more this mindset. And I'm like worried what will happen if, every fork, there's that one small thing that doesn't really align nicely. And we could have just fixed it. If we have that mindset, then in like 5 or 10 years, how many like special edge cases are we really going to have? I think a lot.
Right. I guess given Aragon's comment, does anyone think we should not do this change?
So Dankert had a point about sort of refactoring the execution gas in a way that might make the current thing with 4.4 make more sense. I don't understand, what he's envisioning well enough to really defend it, but I wonder if anyone else has.
Is it written somewhere? I don't think I've seen it.
Yeah, well, so I guess I'm also a little confused. Like, there's like maybe two things here. One of them is just changing how it's just computed and moving to like a nicer sort of math to like better approximate exponentials. Separately, it sounds like this change that we're bringing up right now is unrelated to that, and it's just more about how do we actually validate these things. Is that correct?
Yeah, Yeah, I think it doesn't have anything to do with the exponentials, but more like what is the order of validation / where do you get the data for validating? And I don't think what Dankard is looking at doing involves getting rid of the gas used field, which is like kind of what allows us to make the base fee in the header the base fee for that header's block. And that's kind of what we're missing for excess data gas.
Yeah, so maybe if there was pushback, it was a miscommunication. I'm not sure, but yeah, I mean, does anyone think this is going to push back 444 timelines too much?
Oh, Andrew?
Yeah, just wanted to say, because I think it doesn't. So yeah, I misunderstood it in the beginning because I thought it eliminates the need to get. So it's not relevant to parent bodies. So I need more time to look at the proposal. So I don't have a position on it at the moment.
Does it make sense? We have the 4844 call on Monday. Does it make sense to give people like the next 2-3 days to look over it and make a decision on the 4844 call Monday?
Sounds good to me.
Yeah. And if people can't make that call, just leave your comments on the PR directly, and we can we can consider those on the call. Okay, next up, another PR. Oh, please.
Sorry,
Yes.
can I just add one more thing? Georgios actually asked how this whole thing relates, for example, to light clients. If you want to just verify the headers but don't have the bodies, because obviously you don't download the bodies. And the short answer is that a light client will not be able to verify the access data gas in its current form. So the same way that a light client cannot verify the gas used field because you need to run the transactions, the same way a light client cannot verify the access data gas, the part of it which tracks how many blobs were included. And the other problem, this is another one of those weirdnesses, because even the light client can verify the base fee, but it won't be able to verify the blob fee because of this dual nature of the access data gas. So for light clients, you would just need to take it for granted that that field is correct. But yeah, again, with light clients, it's if we're following if we assume that the consensus network is on a semi-good chain, then a lot of validations could be omitted. I mean, you could even debate that if the consensus client tells you that this is the header, why even bother validating anything? Just roll with it. So yeah, again. So it's not really end of the world. It's just a quirky thing that we have to decide which quirk we want to live with.
Got it. Thanks. Okay, next up, this is like an old PR that recently had some movement. So refactoring the validity conditions for blocks. So I believe, was this the thing where the blocks didn't actually check whether the blob cap was exceeded and only the individual transactions did?
Yeah, so Ansgar is working on this. I don't think he can make the call, so I will answer any questions on this PR. And yeah, that's basically it. Some things kind of got dropped, and I think the main change at this point is exactly what you said. So there's no way currently in 4844 to specify that there's only so many blobs per block. If you look at the current spec, I could send maybe only a few blobs per transaction, but I could send, you know, as many transactions as I can pay for. And then now there's like, you know, 30 megabytes of blobs. So it'd be nice to have this defined at the EL, and that's what this change does.
Got it. Anyone opposed to this? Like, it seems pretty straightforward. Okay, then I guess we could probably go. Oh, yeah. Go ahead.
Sorry, I was trying to find the button. So, I think it was Dan yesterday who said that this field is already validated by the consensus client. My 2 cents, I already wrote it on the channel too, that in my opinion, it would be nice to have it validated by the execution client too, simply because, well, one, it is simpler and safer. And the other is that I think it would be useful to have the validations somewhat self-contained. So basically have everything so that if I just give a batch of blocks to the execution client, then it can do as much validation as possible. Maybe it cannot do chain selection, but it should be able to verify everything else. And this extra check is needed to forbid blocks containing hundreds of blobs.
Yeah, I think we all agree. And so, yeah, like it seems to make sense to me to like keep this in line with execution gas, where it's like, yeah, there's a limit at the EL, and that's sort of the ground truth. There is a cap at the CL, but that's more a networking thing at this point. And again, as we've discussed, you could imagine those kind of varying independently, subject to each layer being uncomfortable with that.
Cool. Okay, so I guess we can go ahead and merge this, whatever, and Scar is ready. Okay, next up, okay, so Devnets. So Barnabas, you wanted to give a quick update on Devnet 5, and then Gajinder, you had 3 PRs related to Devnet 6. So let's do that. Barnabas?
Yeah, sure. So to recap it, in the past 2 weeks, we had a long period of non-finalization on Devnet 5, and it ended up draining 900 validators' accounts to force them to exit. And we managed to get into a finalist state again with Lighthouse and Nethermind. And at that point, we had 100 validators running on a single node, and everyone was able to catch back to that using checkpoint sync. And I decided to make some new deposits so we can still see if any of the validators go offline now. So I made 1,000 deposits yesterday to it, and these are being processed right now. I noticed something that everyone get ejected about at balance of 31.7, which is a bit strange because in the config I have set it to being ejected at 31. So I'm not quite sure why that happened. Here you can see the config for this. And in the interrupt channel, we had some discussion about it. And I will also paste that.
Oh, Ben says hysteresis. Can you expand on that?
If my microphone's working.
Yes.
Yeah, it would be based on the effective balance, and when the node's balance drops below 31.75 ETH, the effective balance drops to 31 ETH. So if you set the ejection balance to 31, then when the actual balance reaches below 31.75, then you'll trigger the ejection, which sounds like what you're seeing.
Okay, yeah, that makes sense then. I had no idea. Anyway, right now we are finalizing, and we have what, 500 validators on the chain right now. It's looking quite nice now.
Nice.
We also have a Beacon Chain Explorer running with no SSL right now. But another thing is Devnet 6 specs are being collected right now, and I'm open for including anything or not including anything else. We have a link for that too. There's quite some PRs that I would like to include in DevNet 6, and this would still be a 4844 specific DevNet, and then hopefully DevNet 7 would be a Bencon DevNet which would combine other PRs that are not related to 4844 also.
Nice.
And that DevNet 7 would come in a, I don't know, but first we should focus on DevNet 6 launch.
Yeah. Yeah, that sounds good. And I see, okay, so I'm looking at your docs now, and I think some of the PRs, yeah, basically a lot of the red PRs are the same ones Gajinder had up. And I think it makes sense to probably take most of the call on Monday to go over this list that you have. But Gajinder, do you want to discuss the three that you brought up on the agenda for today? So first of all was 7038.
Yeah, hi, Tim.
Yeah.
So 7038. Okay, so what 7038 does is it basically refactors a little bit how the network payload is built. So it's now first the transaction payload, then blobs, then commitments, then proofs. Earlier, it was transaction payload, then commitments, then blobs and proofs. So it just, I mean, it feels nice this way. And the second thing, it also adds clarification that the blobs are flat. Otherwise, there was this interpretation that we also had discussion in the Discord that each blob itself is a list of field elements. So this PR also flattens out the blobs and in a big endian way. So and then it just clean up some references and add some validation conditions that were missing.
Okay. Yeah, I see there's been a couple comments on this, but any other thoughts from anyone on the call? Okay, next up. So this is following our discussion last time. Following our discussion from last time about the precompile inputs to be encoded as big endian. Yeah, any thoughts or yeah, comments about
I think in the consensus specs, the KZG big endian change has already been merged. So
okay.
This is quite natural then.
Sorry, someone else was trying to say something. Okay. Yeah, assuming there's no more issues, we can probably merge that as well. And then, okay, this one was to the execution APIs to basically add data gas use, data gas price to receipts in 4844 transactions.
Yeah, it just has those fields in the RPC response.
Yeah. And I guess, yeah, anyone have strong opinions about this? Okay, so it probably makes sense to include it. And I think like client had a comment there saying that we want to wait until we effectively have the full set of changes for Cancun so that we can merge them all at once. But that seems to be the only concerns. And Roberto saying that, yeah, some EL clients already have prototypes for this. Okay, so I think that's all we had in terms of PRs for today. And yeah, let's go over Barnabas's list for DevNet 6 in more depth on Monday's call. as well as the PR that Matt opened, which I'm now forgetting what that one was about. Scrolling up. Sorry, I have way too many tabs open here. The data gas used to the header. So let's discuss that more thoroughly on Monday as well. Cool. Last thing for 4844. So we agreed to move it to RLP. That said, we had basically included the SSZ optional EIP in Cancun, and we'd also CFI'd 6493, the SSZ transaction signature scheme. There were some comments that we should remove those. There was some comments that we should remove those, given we've moved 4844 to RLP instead. Does anyone think we should keep any of the SSZ EIPs either CFI'd or included in Cancun? Okay, no objection. So, okay, I'll do this after the call. I'll take 6475 out of the included list, and I'll remove 6493 from the CFI list. Okay, anything else on 4844? Okay, then next up. Oh, yes, please go ahead.
Small question. Should we can we have empty true field in BlockTX? As far as I remember, we didn't want that because of SSZ uncertainty in terms of encoding and so on. But for now, we can have it like MT2 in RLP. Do we need still to prohibit MT2 field?
I'm sorry, I'm not sure I quite understood. Is this about the contract creation?
Yes.
Yeah, so banning contract creation from block transactions, right?
Yeah. What is the reason? Could you, do some words? Someone who has great motivation to ban this ability.
I can take a stab. So the original reason was partially motivated by the fact that this thing was not well specified in SSZ, but I think that there's still a good reason to do it, and that's that we have these two opcodes for creating contracts, and there's not really any particular use case that I'm aware of where we have to have the ability to create a contract via an EOA. And through the hard forks, we've seen that this is one of these frustrating things to test, because for every kind of change to the transaction, and often for new opcodes, new functionality of the EVM, we have to test in the context of both just normal execution, and then always in the context of a NIC code, both in the context of it with create opcodes and in the context of the create transaction. So I would like to start moving away from using, having create transactions in general, and simply rely on just the create functionality within the EVM.
I see sense.
Okay. Anything else on 4844? If not, okay, so Dano, you put together this document because we're proposing a bunch of opcodes for Cancun and Prague, and it's all starting to be a mess, and you have a proposal for how we can make it a bit cleaner. I'm not sure if you're speaking, but you're.
Okay, now I'm unmuted.
Yes, you're unmuted now, and we see your screen.
That's what's, yeah. So this is like Tim said, there was a lot of opcodes coming in and a lot of space being occupied and moved around. Part of it, I'd have to say, was the early responsibility of the EOF, because they were occupying 3 key opcodes, the last of the 5 series, so here's a quick overview of the opcode blocks we currently have right now. 5 is what was basically filling up, having the storage memory control flow, and that's where the initial EOF control flow opcodes went in. So the proposal starts with a couple of philosophies. One of them is to move all EOF only opcodes that only make sense in EOF opcode containers to a separate block, the E block. And that moves the 500s out of the 5Xs out of there. And then move everything back to the block where it makes the most sense. So that would then move T-load and T-store back in the 5C and 5D, probably M-copy if it passes into 5E. This does not affect blot hash or beacon root. Beacon root might be out. That's a late breaking change overnight. And then some proposed changes in the F series. F series is filling up. There's another proposal for another series of call 2s later on in this meeting. So reserve space for those, reserve space for pay, and I guess we need a reserve space for set code, as mentioned earlier in the meeting. But the purpose of this is to get a more sensible packing and grouping of the opcodes and to fill in the space left by EOF moving into its own block. So this is what's proposed. T-store and T-load are currently in, and everything else, and blot hash is in, everything else is speculative to be added at some point, if it added at all.
Thank you. Anyone have thoughts, questions, comments?
Can we assign set code in this meeting?
Again, until it ships, they could move away. But my thought is it should be in the F series rather than the 4 series. And I think the last F series available is FC. So we could put that in as the current location for it.
Okay. Alex?
Yeah, regarding the EOF side, we have been discussing, these opcodes in like the last 2 or 3 EOF breakout calls. So I think we're gonna do this in any case for EOF. And I mean, there's no question about that. We were really in favor of moving it from the EOF side.
Sweet. Anything?
There was a bit of discussion of putting mcopy at 0x4f, which is like slightly before the 0x5 series. But I don't know if that really makes so much sense. It was just an idea.
So the reason I wouldn't want it in 4F, because those are all focused on block data ones. Stuff that might come in from the environment, what's in your block headers. The only reason that push 0 got put into 5F is because of some fun math relating to the push series operations. Otherwise, I would have put it somewhere else rather than in 5F. So putting mcopy at 4F, I don't think makes quite the same sense. I think a better home with it would be at 5D. I think 5E is where it would be at.
Yeah, okay.
Cool. Is this something we should try and put somewhere better than the HackMD under your handle?
Yeah,
I know we have something similar for transaction types somewhere. Execution.
So that's exactly what I was thinking. I wasn't sure if the right place for this was for the execution specs, or is it informative EIP? So to get the discussion rolling, I just did my own HackMD, put it into the link, and then we can move it in and out. And if it's kept there, it should be kept a live document. As proposals become non-viable, they should be removed from the list. And as they become viable, maybe some speculative opcode placings, but again, shipping opcodes get priority over discussed opcodes.
Yeah, I think where is like client, are the transaction types in the execution specs? Is that where we list them?
Yeah, they're in a folder called lists/signature-types, and there's a README in there, and that also keeps track of tentative signature types. So this is this pretty similar thing. I don't think it would go in the folder lists. I mean, maybe, but yeah, it makes sense in execution specs in general.
Yeah. Yeah, I kind of
Okay.
like lists because like I
guess it is a list of opcodes.
And the thing is, it's a list of like semi-reserved opcodes, right? It's not the spec. Like once they get merged, they become the spec, right?
Right.
But this is like a tentative list.
Yeah, I mean, I think it fits well within the other stuff, like having CFI, EIPs, and just having like an idea of proposed changes for forks. This is just a different way of looking at the proposed changes for forks.
Yeah.
Okay, I'll make up a PR for execution specs that includes all this, and I'll try and follow the signature types. But are there any objections if I were to open up PRs against T-Store to move the opcodes for Cancun? All right, I'll do that today too.
Cool. Yeah, thank you. This is a really great talk. Yeah. Okay. Couple more things. So on the last call, we briefly discussed trying to make some decisions on this call about any other EIPs we might want to include in Cancun. So a couple, I guess 4788 has had some updates since the last discussion, and then I believe there's a new proposal for revamped call instructions, and there's a whole bunch of other proposed EIPs. So I guess quickly, maybe Alex Stokes, do you want to give a quick overview of the changes to 4788? Then Alex Baragasi can give a quick overview of the call EIPs, and then we can hear from clients about what they feel might make sense to include in Cancun.
Sure. So this kind of continues from AC/DC last week. The way that 4788 was before the current update was that it would add a new opcode, something like beacon root, and that would basically call out to some storage in the execution state where these block roots would be. This is like kind of merging two different mechanisms with like some sort of precompile like thing and an opcode like thing. So we kind of decided it would just be cleaner to bite this bullet on a stateful precompile. And so that's what the current update does. Yeah, basically it's just a precompile like we're all familiar with. It happens to have access to the execution state, and that's where this data is stored. This is a bit different from say like how Blockhash works today, where rather than read the execution state, there's this history buffer that just happens to also be there. And the idea is that, you know, in an ideal world, the state transition function for Ethereum would be a pure function of the state and not rely on this like other little history thing. And this has implications for stateless clients and things like that. So I think well, at least people who have engaged with us so far, I think generally like the stateful precompiled direction. Marius has an implementation in Geth, I think for both things, but definitely the stateful precompile. And yeah, I think the change has been merged already. So yeah, I think that's not too controversial. The other big thing was, and probably the last question on this was just discussing how we actually want to key these roots. So we assume then we have the stateful precompile, and now we basically need like some input data to like, you know, figure out, okay, at this slot or maybe this timestamp, what was the actual beacon root? Yeah, so from here, those are probably the two big contenders, is like either using the EL timestamp, which is sort of a proxy for slots, or introducing some way to map into the CL slots while we're writing this thing into the EL state and doing that. So the catch there is that we don't want to violate like the barriers of abstraction between the EL and CL. So it's a little tricky. Yeah, I guess maybe I'll just pause there. Does anyone have any questions so far? Okay. The one thing from here then is maybe if I can just ask Marius directly, because he had some feedback via the prototype. Yeah, I can grab it. Is Marius still on the call?
Yes,
Yeah, okay.
I'm here. So the prototype is very prototypey, and it has both the stateful precompile and the opcode implemented. In the beginning, it was specified as an opcode, but I think an opcode, basically the opcode, like the idea is that this data is going to be in the state, because otherwise we would have a separate storage segment that nodes would need to maintain, and which would complicate the state transition function. Basically, the state transition function would then be the state, the transactions, the header chain for the last 128 headers for the block hash opcode, plus this additional storage segment that keeps the beacon routes. And so what we decided on is to move this, well, what Alex proposed was to move this into the state. It feels kind of weird to put something from outside into the state, but it's, I think, the best. It needs some getting used to, but in the end, I think it's kind of fine. And the why we decided against the prototype, or why I am against not the prototype, the opcode, is that this opcode would read storage slots from a specific address, but that would mean we have this kind of address that has some storage slots that is not really a precompile, and so that it would introduce a new paradigm. So we have to introduce a new paradigm somehow, and so I think the best way to do it is to just add a precompile that returns this data. And now the only open question for me is, how are we going to key this data? Basically,
yeah. And so in the prototype, I think you just wrote like the timestamp from the header, which at least to me is like half of the problem. So the problem with this is that if there's skipped slots, it's like very unclear to the caller how to like find the actual next route.
Why?
Because there would be gaps, right? So like basically you're saying, timestamp, let's say T0, I write the route. Let's say there's like 4 missed slots, and then now there's like some timestamp from like, much greater than just 12 seconds. And then if I want to find the block route for the next thing, it's just like, because the way that it's written is I would read back, basically 0 as the root, and then I would not really know what to do. I would need to like jump forward some amount that I just really don't know. And then have to like search through the contract basically.
Yeah, but so I'm not really sure how this would be used by contracts.
Yeah, so that, that's a good question. So like one example would be, I have a slot, and I guess where I'm coming from is I don't know if it's missed or not. I just have some slot because like, I know there's 64 bits and I can just pick one out of that type space. So I have some slot, and then I want to know what the root is. And like that would be the API I would like. the thing that you were kind of suggesting is more like, I, as the caller, also need to know kind of ahead of time that like there was already a block there, which, you know, might be an okay relaxation.
Or we could even turn it around and say that it's keyed by beacon root, and the value is the timestamp. So the caller could say, I have this beacon root. What is the timestamp for it? If it's only about needing to know that a specific beacon root was there at some point.
Right. So yeah, let's zoom out a bit, just to respect everyone's time here. Has anyone else looked at this and or feel strongly about including this in Cancun?
Oh, I don't feel strongly about including it in Cancun, by the way. I think it's nice and it should be included, but I'm not sure if we should include it in Cancun.
Okay. Does anyone else have any input? Because I think we can resolve this like key question one way or another, and then from there, it's just a question of, do we want to also include it in Cancun? It would help a lot of different applications that people want to use. Like, for example, in the chat, Georgios called out, you know, all sorts of things around accessing beacon state and execution layer. And the other thing is this does kind of tee up other things in future forks, like EL initiated exits. So there's ways in which this like tightens up the staking model that are like really valuable, and this change kind of lays the groundwork for that. So in that sense, I think the sooner the better, just because it unblocks this other stuff we want to do.
And I guess, yeah, maybe if no one has strong opinions on this, do client teams have strong opinions on if they want to include anything else at all, or not for now, and if there are things, you know, that are not for 788 that they want to include?
We would like to include 5920 pay opcode. It's a simple usability improvement.
Okay. Anyone else have thoughts, proposals?
I mean, it might be helpful just to hear, you know, beyond what we currently have, which is what, 4844, T-Store, and one of the self-destruct things. Like, do we feel like there's room for another EIP at all?
Could we discuss mcopy and pay?
And okay, 2537 as well, which is the BLS recover. Okay, so I guess we have 4 minutes. Yeah, maybe if we can do, like, if anyone has thoughts, we can do mcopy, pay, and then Alex, if you want to do the calls opcodes. But yeah, let's start with mcopy. Charles, do you have an update on it, or do you just want to get the feeling from people?
There's no update on it. I brought it up a couple calls ago, and I think you said you wanted to give everybody time to review it, and I think people have had time to, you know, review and think about it. So I guess maybe we should discuss if there's any reservations. I think Marius said, you know, maybe, you know, along with T-load and T-store, it's too complicated, which I don't. My personal feeling is that I don't know about that because, you know, they're affecting completely different separate regions of the EVM. But if anybody else has similar or other concerns, I think we should discuss those.
Dano?
So mcopy is relatively easy. It's kind of like the return data copies. There's a lot of well-worn testing path on that. So I want to hear Marius's opinion. But for pay, I think we need to discuss it in context of the new Call 2 series and as to why pay is needed. If it's just to make things cheaper, I think Call 2 will handle it. but I don't think we have time on this call to discuss the pros and cons of pay versus call to.
Pay is not just for gas. There's a number of high-profile reentrancy attacks involving sending ether that would be easily prevented if people had a way to transfer ether without transferring execution context.
So I think the pay opcode kind of enables. I think it's kind of good. It's something that we should do, but it warrants a whole new, like, we really need to look at the implications of it. Basically, it enables a new way of a contract touching another one, and so this is usually where like most of the bugs are. I don't think we have, like, I personally don't think we have enough time in Cancun for testing this with all its implications it has on the other on the other things.
William?
Regarding the pay opcode, we already know that contracts can receive ether in other contexts, such as from mining new blocks and from self-destruct. So the pay opcode shouldn't introduce any new security considerations because anything that it allows is already allowed.
It's not about security and considerations on the smart contracts. It's more about like how is it implemented, and like basically we need to test this opcode with every combination of everything ever, and this is kind of makes it very complex.
Okay, and we're already at time. Alex Bergassi, do you want to give a quick overview of your EIPs, just so people have the context?
Yeah, so it is called revamped call instructions, and it was pushed into the EIP repo only today, but the work has been, and the number is 7069. But the work on this has actually started in January during Edelweiss, where the requirement for EOF was brought up to also try to eliminate gas observability. And we designed the replacement call instructions at the time with that in mind. But then maybe like 3 EOF breakout calls ago, we realized that these instructions are actually not dependent on EOF, and they could be just introduced in the current EVM. And there are two benefits to doing so. One, if you read the specification, it actually simplifies a number of rules regarding gas. And there's a number of cases where it would be actually much cheaper and better to use these new kind of call instructions instead of the current ones. So existing legacy contracts who choose to do so would benefit. And the second reason why it would be beneficial is if this would be introduced in a different hard fork than EOF, then the EOF changes would be much smaller, because the only change there would be to reject the current call instructions, and these new proposed call instructions would be already there. And then, what these instructions actually do, basically there's the gas observability, which is, one big push we wanted to get rid of. So here we remove the gas limit input, and we just rely on the 6364 rule. We also changed the way the stipend works. It is much more simplified. There's no output buffer address because return data copy and return data size can be used instead of that. There has been a number of discussions with Solidity how it actually uses the call instructions, and some discussions with Viper. And then the last change is the return value. It actually returns more. It returns success, revert, and failure. And back when the revert feature was introduced, there was a plan to add that status code to the calls, but it couldn't have been done at that time in the legacy call instructions because contracts were depending on the behavior, and introducing that would have been a breaking change. I guess I don't really have time to go through everything, but there's one more comment I wanted to make. So there's this version of the EIP, which is in draft mode. But as we went through it, we realized that there would be another option as well, which would mean that these call instructions they would check whether the target is an actual contract. So it would do an Xcode size check. And the call would fail if it's not a contract on the other side. Doing so would simplify the rules even further because these call instructions would only be usable to interact with contracts. What this would mean is that something like a transfer or pay instruction, a separate transfer or pay instruction would be needed in order to establish value transfer to EOAs or non-executing transfers to code accounts. Yeah, I think that's in short. And ideally something like this would be included in Cancun, and then EOF would be much more simplified for a fork afterwards.
Thank you. Okay, we're already quite past time. I don't know if people have comments on on this specifically. If not, I guess what I'd suggest is clearly it seems like we're probably not in a spot to make like the final decisions about smaller EIPs today, and we're not even in a spot where 6780 and 4044 are fully implemented in clients. So I would suggest, I don't know if we want to CFI them, but it seems like mcopy, pay, these call opcodes, as well as the existing BLS precompile and 4788 EIPs are sort of the ones we're considering. So should we move those three other ones, so like 5920, 5656, and then the call one to CFI, and sort of restrict the discussion at those? And yeah, we can see in the next couple of weeks how things progress. Does anyone object that?
That sounds fine. I don't think we should add more. And if anything, we should probably bias towards just freezing the current set. But,
right. Yeah. So that's what I'm saying is like we freeze the current set with those things.
Mm-hmm.
Everything else is de facto sort of excluded. Obviously, if there's some last minute issue, we can always change things, but that gives us like 3 EIPs currently in the fork, and we'd be up to, I believe, 5 CFI'd ones because we have 3 now, adding 3 and removing 1.
Right. And 444 is a big one, just
yes,
so we're all aware.
Yes. Okay, we will let them know by client. Sweet, let's wrap up here. We're already over time. Appreciate everyone sticking around, and talk to you all on the next one of these.
Thanks, Tim. Bye.
Thank you.
Bye.
Bye. Bye.
Thank you.
Thank you.
Bye. Thanks.
Bye.